Hello, can anyone please confirm whether am I audible or not? Hello. Hello, am I audible? Can anyone please confirm?
Ma'am, increase your voice.
Okay, okay. Good evening everyone. I am Riya Tapwal. I am doing PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur, and today I am here to discuss the topic of week 3, and after that I will discuss the question of assignments of week 3. So first of all, we will discuss about two protocols, that is HART and wireless HART. So if you remember, last week we discussed about IEEE 802.15.4 and some of the protocols which are the extension of the same. So basically this HART and wireless HART is also the extension of IEEE 802.15.4 protocol, and this HART stands for Highway Addressable Remote Transducer, and it is a standard which was developed by Network Smart Field Devices. And wireless HART is the latest release of your HART protocol, and it was made in order to make the implementation of HART cheaper and easier. So basically HART encompasses the most number of field devices incorporated in any field network. So basically field devices are your sensors, actuators, PLCs, all those things are your field devices. Now a wireless HART enables device placement more accessible and cheaper, such as for example on the top of your reaction tank, inside your pipe, or widely in the separated wire houses. So all the devices which are placed in such areas, the communication between these devices can be made possible with the help of wireless HART. The main difference between your wireless and wired HART lies in your physical data link and network layer. However, your application layer is seamless or common in both your wired and wireless HART, and your network and transport layer is merged together in a single layer, that is called your network transport layer in case of your HART. And your wired HART lacks your network layer. So in your wired HART there is no network layer. Now these are the description of various layers which a HART consists of. So first of all, HART physical layer. So it is derived from IEEE 802.15.4, as I have already told you. So it is just the enhancement of this protocol. It operates only in 2.4 gigahertz ISM bands and employs 15 channels of the band to increase reliability. So if somehow one of the channel is down, then we can use the other channel. So basically your HART physical layer is using 15 channels. The second layer of HART is your data link layer. So the main functionality of data link layer is to provide collision free and deterministic communication. So this is achieved with the help of your super frames and TDMA. So this super frames consist of grouped 10 ms wide time slots. So if you remember, in computer networks, in order to access the same channel by different users, we have different multiplexing methods. For example, your TDMA, FDMA, WDMA. Okay, so your HART is using TDMA, and in case of HART, the time slots which is used in TDMA is divided into 10 milliseconds, and a super frame is the group of those 10 milliseconds slots. After that, super frame control the timing of transmission to ensure collision free and reliable communication. This layer also incorporates channel hopping and channel blacklisting to increase the reliability and security. So basically, in case of HART, what happen is the users which are going to send data is not sending the data through a single channel only. Since there are 15 channels, so every time the transmission is made, the channels are switched. This is called channel hopping. So this will improve the security basically, because if the attacker knows that that particular user is going to send the data through channel A, then there is a high possibility that the attacker is going to attack on that channel. But if there is a continuous or frequent hopping between the channels, then the chances or possibilities of attacks will get reduced. Further, channel blacklisting means in case of channel blacklisting, it identifies the channel which are consistently affected by your interference, and in case of blacklisting, we are going to remove those channel from use. The third layer is called your HART network and transport layer. So it cooperatively handles various types of traffic, routing, session creation and security. Wireless HART relies on your mesh networking. It means that each device is able to interact with every other device present in the network. Then each device is armed with an updated network graph. So basically, whenever there is some changes in the network, each device is getting to know that there is some addition in there is some addition of node in the network, or there is some deletion of node from the network. Okay, and in case of your HART, network layer consists of your network layer, transport layer and session layer of OSI. So all the services which are provided by your network layer, transport layer and session layer in OSI, in case of HART, only the network layer provide all the functionalities. Then the last layer is application layer. So this layer handles the communication between the gateways and devices by a series of commands and response messages. This is also responsible for extracting the commands from the messages and further executing those commands and then generating the responses accordingly. This layer is seamless, as I have already told you that in case of wired or wireless, the application layer is common. Now the congestion control in HART. So interference prone channels avoided by using channel switching post every transmission. Okay, so basically in case of your HART, what we do is we do channel hopping continuously or after every transmission. So what happen if there is a particular channel in which there is lots of interference, then due to this channel hopping, this interference channel is going to be avoided. The next point is transmission synchronized using 10 ms 10 millisecond slots. So with the help of these super frame slots, that is your 10 milliseconds slots, the synchronization can be provided for your transmissions. During each slot, all the available channels can be utilized by various nodes in the network, allowing for the propagation of 15 packets through the network at a time, which also minimizes the risk of collision. Because in case of HART, 15 channels are used, so at the same time we can send 15 packets. Now wireless HART network manager. So this network manager supervises each node present in the network and guides those nodes that when to send the data, where exactly to send the data. So this helps in order to avoid the collisions, and also helps in the yeah, hello, anybody is saying something? Okay. Yeah, your network manager is also responsible for the timely delivery of the packets from the source to destination. Your network manager updates the information about the neighbor, signal strength, information needing delivery of receipt or a receipt. So basically, whenever there is some change in the network, this network manager is going to update the information to each of the nodes. It also decides that who will send the data, who will listen to the information, and what will be the frequency of each time slot. It handles the code-based network security and prevents the unauthorized nodes from joining the network. Now, the second protocol which we are going to discuss is your NFC. So, NFC stand for Near Field Communication. This is an extension or offshoot of your RFID, that is radio frequency identification. Last week we have already discussed about your RFID. It is designed for the use by devices which are in close proximity of each other. So the devices which are very close to each other can use NFC in order to communicate with each other. So Felica is one type of NFC which is commonly used in Japan. Now the types of NFC. So basically there are two types of NFC. First one is your passive devices and second one is your active devices. So passive devices contains the information which is readable by other devices. However, it cannot read the information itself. So passive devices are the devices which can only provide the information. A reader is not there in your passive devices. However, in case of your active devices, reader as well as information is available. So active devices can also provide the information as well as it can also read the information. Okay, so the example of passive devices are the code which is over your various products, electronic products or other products. However, your active devices are your smartphones, because smartphones can provide RFID code also, as well as they can also read the code. Now the working principle of your NFC. So it basically works on your magnetic induction principle. So what happens is your reader emits a small amount of current, due to which magnetic fields generate, and that magnetic field bridges the gap between the reader and the tag, that the other device over which tag is present. Now similarly, over that tag some magnetic field is also there. So there is some interaction between the two magnetic fields, and the information get exchanged from the one device to the other device, that is from your tag to the reader. Now in case of your passive device don't have their own energy. So they are getting energy from the reader in order to transmit the data. However, your active devices, which are also called your peer-to-peer tags, have their own power source. Now the three modes in which NFC can work. First one is your peer-to-peer, second one is your read-write, and third one is your card emulation. So in case of your peer-to-peer, the two devices can swap data. So basically both the devices can exchange data between each other. So smartphones can be the example. So a smartphone can exchange data or swap data. In case of your read-write, one device actively pick up the information from the passive device. So this active device is going to read the data from your passive device. And in case of your card emulation, NFC device can be used like a contactless credit card. Now the application areas where NFC can be used. So first one is your smartphone based payments. So this is very common application which is used. Second one is low power home automation system. So NFC can be used in your home automation systems also. Information tags in posters and advertisements. So there are tags sorry, over your posters and advertisements. So there also NFC is used. Computer games, synchronized toys, Then for parcel tracking also, in case of your supply chain, NFC can be used in order to track different parcels or different products from the supplier to the manufacturer. Now the third protocol is Bluetooth. So Bluetooth is a wireless technology which is used for short range communication. So the main motive behind its development is to replace the cables or the portable units which are used to exchange the information. Further, it also provides high level security, and it is based on ad hoc technology as well as your ad hoc piconets. So ad hoc technology means in case the connections are intermittent, so the connection can be established or disconnected over the air, and ad hoc piconets we are going to discuss further in these slides. Then Bluetooth technology operates in the unlicensed industrial, scientific and medical band at 2.4 to 2.485 gigahertz. Okay. It uses spread spectrum hopping, full duplex signal at nominal rate of 1600 hops per second. Bluetooth support 1 Mbps data rate for version 1.2 and 3 Mbps data rate for version 2. Now the operating range depends on the device. So there are three classes basically. So class 3 radios have the range of up to 1 meter to 3 feet. Class 2 radios are most commonly found in mobile devices, and the range is 10 meters to 30 feet. And class 1 radios are used primarily in industrial use cases, where the range is 100 meters to 300 feet. Now the connection establishment in Bluetooth. So this connection establishment is divided into 3 phases. First one is your inquiry, second one is your paging, and third one is your connection. So in case of your inquiry phase, what happened is one Bluetooth device is going to discover the other Bluetooth devices which are near to that. In case of your paging, the process of paging is the process of forming a connection between the two Bluetooth devices which are present in that network. However, in case of your connection, the devices either participates in the network, or they can also go to the sleep mode if there is no exchange of information. Now the modes in which Bluetooth work are 4. First one is active, second one is sniff, third one is hold, and fourth one is park. So in case of your active mode, the devices are actively transmitting or receiving the data. In case of your sniff mode, the devices either sleeps or they can listen to the transmission at the time at the set interval. And in case of hold, the devices are in power saving modes, where a device sleeps for a defined period of time and get returned back to the active mode after that particular period of time.
Screen is not visible.
Screen is not visible. Hello.
Yes, ma'am. Screen is not visible.
Okay. Now. Wait.
Madam, you need to reset the screen again.
Yeah. Actually, some people are joining, so I am admitting them all. Now is my screen visible?
Yes, ma'am. Yes, ma'am.
Okay, thank you. So yeah, we have discussed four different modes of Bluetooth in which your Bluetooth devices work. Now after that we will discuss about various layers which are there in Bluetooth protocol. So first layer is your baseband. So this is baseband is the physical layer of Bluetooth which is used to manage all the physical channels and links. The other services which is provided by your baseband layer or your physical layer of Bluetooth are your error correction, data whitening, hop selection, Bluetooth security. All those services are provided by your baseband. It also manages asynchronous and synchronous links and handle packets, paging and inquiry. The second layer is your L2CAP, that is your logical link control and adaptation protocol. It is layered over your baseband protocol. So basically first layer is your baseband and over that it is your L2CAP. It is used to multiplex multiple logical connection between two devices and provide connection oriented as well as connectionless services to the upper layer protocols. It also provides protocol multiplexing capability, segmentation and assembly operation and group abstraction. Now RFCOM, so it stands for your radio frequency communication. It is a cable replacement protocol used for generating a virtual serial data stream. So basically in case of your when you are going to send data through wired medium, data is sent serially. So in order to replicate that scenario, this protocol is used. So basically this protocol is going to generate virtual serial data stream through which your data is sent. RFCOM provides for binary data transport. It emulates EIA32 control signal over the Bluetooth baseband layer, that is your serial port emulation. RFCOM provides a simple reliable data stream to the user which is similar to your TCP and supports up to 60 simultaneous connection between two Bluetooth devices. Second protocol is your service discovery protocol, which enable applications to discover various services and their features. It also addresses the unique characteristics of Bluetooth environment such as dynamic changes in the quality of service in the radio frequency proximity of devices in motion. It can function over reliable packet transfer protocol and uses a request response model in order to exchange the data. Now the piconets. So basically in your Bluetooth when two devices connect with each other or communicate wirelessly, so the network which is formed is called your piconet. So Bluetooth device exists in a small ad hoc configuration with the ability to act either as master or slave. So all the devices which are present in the network, they can either behave as master or slave. So provision are in place which allow for a master and a slave to switch their roles. So it is not pre-decided that who will act as master or who will act as slave. So they can switch their roles in between. So in case of your Bluetooth, there is one master node and other nodes which are connected to that particular node act as slaves. So at a time 7 slaves can be connected to a single master, and a single Bluetooth device can be a part of 2 different piconets, and that particular device which is a part of 2 different piconets is called bridge. Now the features of piconet. So within a piconet The clock and a unique 48-bit address of master determines the timing of various devices and frequency hopping sequence of individual devices. Each piconet supports 7 simultaneous connection to other devices. Each device can communicate with several piconets simultaneously, and that devices are called bridges. Piconets are established dynamically and automatically as Bluetooth enabled devices enter and leaves the piconet. There is no direct connection between the slaves. So if two slaves wants to communicate with each other, so two slaves cannot basically communicate with each other, they are going to interact with master particularly. So all the connections are either between master to slave or slave to master. So slaves are allowed to transmit once these have been polled by the master. So basically your master is going to poll all the nodes which are connected to it, whether they want to send the data or not. If they want, then after the polling only they can send the data. Slaves are allowed to transmit once they have transmission start in the slave to master time slot immediately following the polling packet from the master. A device can be a member of 2 or more piconets, and 2 adjacent piconets which are there in the network are called scatternet. So basically your scatternet is the superset of the piconets. Now the application scenarios of your Bluetooth, where Bluetooth can be used. So it can be used in your audio players, home automations, smartphones, toys, hand-free headphones, sensor networks, and other also. Now the next protocol is your Z-Wave. So Z-Wave is a protocol for communication among devices used for home automation. So basically this Z-Wave is only invented for home automation. So in order to make the devices which are present in your home network, to make communication possible between these devices, Z-Wave was invented. It uses radio frequency for signaling and control the devices. The operating frequency of Z-Wave is 908.42 MHz in US. However, it is 868.42 MHz in Europe. Mesh topology is used in Z-Wave, and it can support this Z-Wave can support up to 230 nodes, 232 nodes in a network. It utilizes GFSK modulation as well as your Manchester channel encoding. A central network controller device sets up and manages the Z-Wave network. So basically there is a one controller device which is going to manage the whole network. So each logical Z-Wave network has one home ID and multiple node IDs. So the network ID length is 4 bytes. However, the node ID length is 1 byte. It uses a source routed network mesh topology using one primary controller. The devices can communicate with each other whenever they are in a range, and when devices are not in range, then the packets or messages are routed with the help of hopping or bypassing the obstruction, or with the help of the nodes which are present in between. The process of bypassing the radio dead spots is done using a message called healing. And as Z-Wave uses source routed static network, mobile devices are excluded from the network and only static devices are considered. Next is ISA 100.11a. So it stands for International Society of Automation. Basically it was designed for industrial purposes only. So in order to make the communication possible between your industrial devices, this was designed, and more than 1 billion devices use this standard, and it is designed to support native and tunneled application layer. Various transport services including your reliable communication, best effort, real time are offered by this standard, and network and transport layer are based in this ISA 100.11a. Your network and transport layer are based on your TCP or UDP. and the IP is IPv6. And the data link layer support your mesh topology, mesh routing, and frequency hopping, and your physical and MAC layer are based on your IEEE 802.15.4. so basically this is also an extension of this standard. The topologies which are used are your star tree topology, mesh topology, and the networks include radio link, ISA over Ethernet, and field buses. Now the features of ISA 100.11a are it is flexible, it supports multiple protocols, it there is use of open standards in case of ISA 100.11a. It supports multiple application, it provides reliable data communication, and TDMA and QoS support is there. It also provides security. Now the security in ISA 100.11a. So security, for providing security, authentication and confidentiality services are there. A network security manager is there who is going to manage all the keys between your different nodes, and twin data security is used in your ISA 100.11a. Now the next topic is your wireless sensor networks. So in case of your wireless sensor network, there are various devices, various sensor nodes which are deployed over a region, and these sensor nodes are going to interact with each other wirelessly. So these sensor nodes are capable of collaborating with one another and measuring the condition of the surrounding environment. So that can be your light, temperature, sound, vibration, anything that this particular sensor is going to measure. Now this figure is showing the scenario where various sensor nodes are interacting with each other and further transmitting the data to your this base station. The sense measurements are then transformed into a digital signal and processed to reveal some properties of that particular phenomenon around the sensors. So and the sense data which is sensed by your sensors is further converted into your digital signal, and those digital signals are further processed in order to get some important information from there. Due to the fact that the sensor nodes in wireless sensor networks have short radio transmission range, intermediate nodes act as your relay nodes in order to transmit the data towards the sync node. So basically, for example, here in this figure, this red colored sensor node is going to send data to your sync node. So this symbol here, which is of base station symbol, is your sync node. So if that red color sensor node is want to send data to your
Hello.
Yes.
Oh, sorry for interrupting, ma'am. My friends want to join, but she can't join.
Okay, wait.
Thank you, ma'am.
Okay, welcome. everyone please try to join by 6:05 because it will be difficult for me to every time accept. Okay, so we were discussing wireless sensor networks. So in case of your wireless sensor networks, if a particular sensor node wants to send data to sync node and it is far from that particular sync node, then it is going to utilize the intermediate nodes which are present in between your sync node and your that particular sensor node, and the in between sensor nodes in that case are called your relay node. Now this figure is showing the various components of your wireless sensor network. So first one is your power unit, which is going to provide power to your sensors. Second one is your storage unit. So storage unit is going to provide some storage to your sensor node, so which is going to store some information. The third one is processor unit, which provide processing capability. Fourth one is your analog to digital converter. So as I have already told you that we need to transform the sensed information into the digital signal, so this converter is required. Then the next component is your sensing unit, which is going to sense the environment. Then your transceiver unit is required because we need to transmit the data and at the same time we need to receive the data, because your sync node is going to receive the data, your sensor nodes are going to transmit the data, so we need a transceiver unit also, and your location finding unit. So in order to detect the location where your sensor node is deployed, we need a location finding unit. However, this location finding unit is not required in every scenario. Now your sensor nodes can be multifunctional. The number of sensor nodes used depend upon the application in which we are going to use that particular sensor node. Short transmission ranges are there, and these sensor nodes should have operating system, and these sensor nodes are battery powered, so basically they have limited life. Now the constraints which are over your sensor nodes are so your sensor node should be of small size so that they can be deployed anywhere. They must consume less power or low power, extremely low power. So whenever if we want to deploy our sensor nodes in places where we can't provide power to them, so in that case also your sensor node should live for long. So they should be able to operate in unattended manner in a highly dense area, and they should have low production cost, and they should be dispensable. They should be autonomous and adaptive to any environment. Now the application areas where your wireless sensor nodes can be used. So for measuring your temperature, humidity level, for lightning condition, air pressure, soil makeup, noise level, vibration, and others also. So these are the application areas. These are some of the application areas actually where your sensor nodes can be used. Now these figures are showing various types of sensor nodes. So first one is your soil sensor node, second one is your temperature flux sensor node, and third one is your weather sensor node. Now the challenges which are there in your wireless sensor networks are, first one is your scalability. So the number of devices which are deployed in your wireless sensor networks are very large. So in order to provide services to all those devices, it becomes difficult. So scalability is one of the major issues. Second one is your quality of service. So for all these devices, in order to interact with each other, so there is a need of bandwidth. The delay should be minimum, jitter should be minimum, there should not be packet loss. So in order to provide these services, it is difficult. The third one is energy efficiency. So these sensor nodes have limited power. So these sensor nodes should be energy efficient. And next one is your security. So the data which is generated by your sensor should be secure. Now next topic is your cooperation in wireless ad hoc and sensor networks. So as I have already discussed that in order to exchange the data, there is a need of cooperation between various sensor nodes, right? So the nodes which wants to communicate with each other, they do with the help of intermediate nodes, which are also called your relay nodes. And wireless nodes are energy constrained devices, and these nodes which are intermediate nodes, they may or may not cooperate. Now the two extremities, first one is your total cooperation and second one is your total non-cooperation. So as I have discussed that they may cooperate and they may not cooperate. So in case of your total cooperation, whenever a particular node wants to send data, so all the relay nodes are going to accept the request. So they are going to transfer the data whenever required. Okay. So if this is going to happen every time the intermediate nodes are going to transmit the data, so their energy will be exhausted, right? And they are not getting any profit for that, because their data is not getting exchanged. They are just sending the data of other sensor node. So if they are providing total cooperation, then in that case their lifetime will get reduced. And second one is total non-cooperation. So if there is non-cooperation between the sensor nodes which are present in the network, then what will happen is the throughput of the network will automatically go down, because whenever a particular sensor node wants to send data to the sync node or other sensor nodes, if the intermediate nodes are not going to exchange the data, then that particular sensor node is not able to send the data, right? So in that case the network throughput automatically will go down. Now the issues are which are, first one is selfishness or self-interest. So in first case, as I have told that in case of your total cooperation, if those intermediate nodes become selfish, because their lifetime is going to be reduced if they are going to send the data, if they are going to show total cooperation. So sometimes they also have to act as selfish, but if they act as selfish, then the problem is the network throughput will go down. So this is the issue. Second one is your symbiotic dependence. So symbiotic dependence means all those nodes which are present in the network are depending upon each other, right? So they are not independent, they are not going to exchange the data without the help of each other. So there is a symbiotic dependence in the network. And there is also a trade-off between your network lifetime and throughput. So as I have told you that if there is total cooperation, then lifetime is going to be reduced, and if there is no cooperation, then throughput is going to go down. Now the behavior of nodes in wireless sensor networks. So first one is your normal nodes. So normal nodes are the nodes which are going to work perfectly in the ideal environment conditions. Second one is your failed node. So these failed nodes are the nodes which are not going to perform the operation, that particular operation they should perform. So it could be because of power failures or environmental conditions. The third kind of behavior shown by the nodes are badly failed nodes. So badly failed nodes are the nodes which exhibits the features of your failed nodes, but they also sends the false information or false routing messages. So in case of your failed nodes, they are not going to perform their operation, but at the same time they are not sending any false information. But your badly failed nodes are not going to perform their operation, but they are also sending the false information. Now the selfish node. Selfish nodes, I have discussed already that they are not going to cooperate, or they are not going to cooperate with other nodes for exchanging data. The other types of nodes are malicious nodes, so they deliberately disrupt the correct operation of routing. Now dynamic misbehavior, that is your dumb behavior. So dumb nodes basically means the nodes which can sense the data, or which can sense the surroundings, but they are not going to transmit that particular sensed data. So detection of such temporary misbehavior in order to preserve normal functioning of network, coinage and discovery of dumb nodes. So in the presence of adverse environmental condition, the communication range shrinks. The sensor nodes can sense its surrounding, but it is not able to transmit the sense data. So with the reassumption of favorable environmental condition, dumb nodes work normal. Dumb behavior is temporal in nature. Now the presence of dumb nodes impairs the overall network performance, because if your particular node is not going to exchange the data, then the throughput of the network is going to down, right? So this is going to affect your network performance. So detection and subsequently re-establishment of network connectivity is crucial in your wireless sensor network. The sense information can only be utilized if the connectivity is between such dumb node with other nodes in the network could be re-established. So before restoration of network connectivity, it is essential to detect the dumb nodes in the network. So in order to detect the dumb nodes in the network and in order to re-establish the connectivities between the dumb nodes and the other nodes which are present in the network, there are various schemes present, or there are various schemes proposed by the researcher. So these are the two schemes which are proposed by the researcher. First one is your CORD and second one is your CORAD. Now the event aware topology management in wireless sensor networks. So first one is your timely detection of an event of interest. Second one is your monitoring of the event. Third one is your disseminating the event data to the same. Fourth one is your adapting with the changes of event state. Next one is your event location, then event area, and then event duration. Okay, so detection and connectivity re-establishment. So information theoretic self-management of wireless sensor nodes. So these sensor nodes should be self-manageable. So a wireless sensor node deployed in with the intention of acquiring information should be self-manageable. The sensed information are transmitted in the form of packets, and information theoretic self-management, that is your INTSCM, controls the transmission rate of a node by adjusting the node sleep time. So benefits of this is it reduces the consumption of transmission energy of the transmitter, and it also reduces the consumption of receiving energy of the relay nodes. Now social sensing in wireless sensor nodes. So social sensing based duty cycle management for monitoring rare events in the wireless sensor network. So duty cycle management means these particular these nodes are not going to be awake for full time. So in after particular interval of time, these nodes are going to sleep, and after every frequent interval of time they get awake and going to sense the information and exchange the information. So with the help of this thing, the energy is going to be, the energy consumption is going to be reduced. So the scenarios where your wireless sensor networks or this social sensing in wireless sensor networks can be used is for your event monitoring. So wireless sensor networks suffer from your ineffective sensing from your rare events. So whenever there are rare events, so there is a chances whenever we are going to use duty cycle management, there are chances that we are going to miss those rare events. After that, event monitoring or sensing, even if there is no event to monitor or sense, examples are your submarine monitoring in underwater surveillance. Now the limitation. So this social sensing in wireless sensor network is not going to distinguish between your rare events or your regular events. So it is not going to distinguish whether the event is rare or it is a regular event. It is ineffective wake up and sensing under a rare event monitoring scenario. Now this figure is showing the example of social sensing, which is utilizing duty cycle for these military sensor nodes to awake after a regular interval of time. Now the challenges are wait, someone is there.
Ma'am, can you share this PPT to us?
Yeah, I'll upload the link over the YouTube description only. Last time I have uploaded.
Okay, what is this slide's name?
I'll
On
share the
YouTube?
link again. I'll share the link again today.
Thank you, ma'am.
Yeah. Now the application of wireless sensor nodes. So it can be used in your military missions, your agriculture, then your industry 4.0 also utilizes wireless sensor networks for building smart building monitoring. Also wireless sensor networks can be used in your intelligent home appliances. It can be used in e-health monitoring. It can be used for disaster management. For your intelligent transportation service, your wireless sensor networks can be used. Now the questions. So first question is, in journal, Z-Wave protocol for communication among devices is used for. Options are topology management, home automation, network configuration, none of the above. Anyone?
B, home automation.
Home automation, right. So basically your Z-Wave was invented only for your home automation. So these are the features which I have already discussed. And the reason why your Z-Wave is used for your home automation is Z-Wave provide interoperability between various devices. It is also easy to install. There is less power consumption if we use Z-Wave for home automation. Then interference is less in case of your Z-Wave. It provides secure exchange of information. Then it is scalable, open source and low cost. Next question is, which of the following characteristic of heart data link layer helps it to achieve collision free and deterministic communication? Options are superframe, second is channel hopping, third is channel blacklisting, fourth one is all of the above.
All of the above.
All of the above. It is saying collision free and deterministic communication only. Channel hopping is responsible for providing security, and channel blacklisting is for detecting your the channel which get interference. There is interference in particular channel. However, your super frames are responsible for your collision free and deterministic communication. So answer for this will be your super frame. Now next question is, which of the following is the basis for your Bluetooth technology? Options are ad hoc piconets, second option is your ad hoc technology, third is your both A and B, and fourth one is none of the above.
It's both.
Yeah, right, both. So your Bluetooth technology is based on your ad hoc piconets as well as your ad hoc technology. Now these are the features that your Bluetooth is for your short range communication, replace your cables, maintain high level of security, and based on your ad hoc technology and piconets. Now, which of the following protocol uses healing to bypass radio dead spots? Options are HART, second one is your NFC, third one is your Z-Wave, fourth one is your none of the above. Anyone?
C.
C, right, Z-Wave. So basically, radio dead spots are the zones where little or no signal can be received. So it is within the range of particular radio transmitters, but however there is no signal. So in order to bypass these dead spots, messages are used with these messages are called healing messages, and Z-Waves use these messages. Next question is, which of the following nodes send false routing message in the network? First one is your bad nodes, second one is your badly failed nodes, third one is your failed nodes, and fourth one is your all of the above. Anyone?
B.
D.
B. Badly failed nodes.
B. Badly failed nodes. Right. Next question is, which of the following layer provide multiplexing capability in Bluetooth technology? Options are L2CAP, RFCOM, STP, baseband. Anyone? Which of the layer of Bluetooth provide multiplexing capability?
L2 cap.
Right. So and this is the protocol stack of your Bluetooth technology, and now these are the features. These I have already discussed. Next question is, which of the following component can be considered as optional for sensor node? Options are sensing unit, second option is transceiver, third option is location finding unit, and fourth option is none of the above. Anyone? I have discussed this thing just few minutes back only. What? Speak loudly.
It's C.
C, location finding unit, right? Next question is, which of the following provide energy to peer-to-peer tags? Reader. Next option is they have their own power source. Third option is both A and B, and fourth option is they doesn't require energy. They don't require any kind of energy.
A. Reader.
I'm talking about peer-to-peer tags. So peer-to-peer tags are your active tags.
B. They have own power.
Right. Next question is, which of the following schemes are used to establish the connectivity between your dumb nodes with your other nodes? First one is your CORD, second one is your CORAD, third is your both A and B, and fourth one is your none of the above.
Both A and B.
Right, both A and B. Next question is, which layer of Bluetooth handles paging? Options are L2CAP, second option is RF COM, third option is your SDP, and fourth one is your baseband. Anyone?
Baseband.
So paging is basically the process of forming connection between two Bluetooth devices, and your baseband is going to provide this facility. Now question number 11th is, in journal, is it advisable to increase the duty cycle of node in case of rare events for social sensing? Options are yes, no, not applicable. Anyone please? So duty cycle means when your after what interval of time your sensor nodes are going to awake after sleep.
We know then. No.
No. Why?
It's no only. No.
I'm asking why.
To save power. To save power.
Right. Next option is Zigbee Pro compatible with Zigbee RF4CE? Options are yes, no, not applicable. Anyone?
Yes, A.
No, it's not compatible. So basically your Zigbee Pro, Zigbee RF4CE and Zigbee IP are incompatible with each other. Next question is, which of the following is true? First option is Scatanet is a subset of Piconet. Second option is Piconet is a subset of Scatanet. Third is okay, so now we will discuss about the questions of week 3. So first question is, in journal, Z-Wave protocol for communication among devices is used for. Options are topology management, home automation, network configuration, and none of the above. So basically I have already discussed this thing that Z-Wave is a protocol which was designed in order to make communication possible between different devices which are present at your home. Okay, so this Z-Wave protocol was made in order to make your home automation possible. So all the appliances such as your light bulb, your refrigerator, all those devices or appliances can communicate with each other with the help of protocol, that is your Z-Wave. Now these are the features of Z-Wave protocol. For example, this was especially developed for home automation. It uses radio frequency for signaling and control. It operates in the frequency range of it operates at the frequency of 908.42 megahertz in US and 868.42 megahertz in Europe. Mesh topology is main mode of operation of Z-Wave, and it can support up to 232 nodes in a network. Now the reasons why we should use Z-Wave for home automation are: so first one is interoperability. So Z-Wave protocol provide interoperability between different heterogeneous devices which are present at your home. Second reason is easy installation. So it is very easy to install Z-Wave protocol. Third one is low power consumption. So if you are going to use Z-Wave protocol for making the communication possible between different appliances, then the power which is required in order to make this communication possible is very low. Next point is low interference. In order to exchange the messages, the interference faced by the devices is very low in case of Z-Wave protocol. Next one is security. So Z-Wave protocol provides secure communication between your devices. Then next is scalability. It also supports scalability. It is open source, and it takes very low cost in order to use Z-Wave for home automation. So basically the correct option for this question is home automation. So Z-Wave protocol for communication among devices is used for home automation. Now next question, that is your question number 2, is which of the following characteristics of HART data link layer helps it to achieve collision free and deterministic communication? Options are super frame, channel hopping, channel blacklisting, and all of the above. So basically in case of your HART protocol, three techniques are used basically. First one is your super frame, channel hopping, and channel blacklisting. So we will discuss one by one all the three techniques. So first one is your super frames. So super frames are responsible for collision free and deterministic communication. Basically super frames are the groups of 10 milliseconds by time slots. So this HART protocol basically use TDMA. So in case of TDMA, what we do is we divide the channel into various time slots, and different user can access the channel according to those time slots. So basically these super frames are the groups of those time slots, and in case of HART, the time slots consist of 10 milliseconds. Okay. Next point is super frames control the timing of transmission to ensure collision free and reliable communication. So basically these super frames are responsible for the collision free communication. Next technique is channel hopping. So basically this channel hopping is not used for collision free transmission. However, it is a channel access method in which there is a switching of channels whenever we want to transmit the data. So every time once the transmission is done, the channel is changed. So channel is hopped basically. So this is called channel hopping. So it is used by low power devices in order to communicate with each other using a wireless link. Since every time we are hopping the channel, so it becomes difficult for the attacker to know that through which channel we are sending the data. So channel hopping also results in improving the security. Next technique is channel blacklisting. So in case of channel blacklisting, what happened is we identifies the channel which is consistently affected by interference and remove them from use. So if a channel is consistently getting affected by your interference, then we are going to remove that channel with the help of your channel blacklisting technique. So the correct option for this question is super frames. So super frames are responsible in order to achieve collision free and deterministic communication. Next question is, which of the following is the basis of Bluetooth technology. Options are ad hoc piconets, ad hoc technology, both A and B, and none of the above. Basically this Bluetooth technology is based on both your ad hoc piconets as well as ad hoc technology. So first of all we'll discuss about ad hoc technology, and then I'll tell you what is ad hoc piconets. So in case of ad hoc technology, what happened is the connection between various devices is intermittent. So depending upon the signal which we are receiving, the connection can be established, and automatically it can, or the devices can also get disconnected. And ad hoc piconets so whenever two devices form connection, or two or more than two devices form connection, then the network which is formed is called piconet in your Bluetooth technology. Okay, so in a piconet there is one master node, and all the other nodes which are connected to that particular node are called your slave nodes. So basically at a time there can be one master node in a piconet, and it can connect up to 7 slave nodes at a time. So those slave nodes can be a part of different piconets. Okay, so it is not always necessary that a particular node should be a part of one piconet only. It can be part of more than one piconet, and the nodes which are part of more than one piconet are called bridges. Now these are the features of your Bluetooth technology. So basically Bluetooth wireless technology is short range communication technology which is intended for replacing cables connecting the portable units. It also maintains high level of security, and it is based on your ad hoc technology and also your ad hoc piconets. Now I have already discussed that what is your ad hoc technology and what is ad hoc piconet. So in ad hoc technology the devices spontaneously connect and communicate with each other. However, your ad hoc piconets, ad hoc network that links devices using Bluetooth is called your ad hoc piconet. It consists of 2 or more devices. It allows one master nodes to interconnect with up to 7 active slave nodes. Now next question is, which of the following is the this is the same question, that which of the following is the basis of Bluetooth technology. So both A and B are the correct option for this. Next is, which of the following protocol uses healing message to bypass the dead radio spots? Options are HART, second option is NFC, third option is Z-Wave, and fourth option is none of the above. Now first of all we should know what exactly is this radio dead spot, because we are the question is that which of the following protocol uses healing to bypass this radio dead spots. So in order to answer this, first of all we should know that what exactly is radio dead spot. So radio dead spots are the zone where there is no signal or there is very little signal. So basically these zones are within the range of transmitter, however due to some reasons there is no signal at those places. So if we want to transmit message between two devices and there is some dead spot in between, then how this is possible in order to bypass those messages? So in case of your home automation systems, the possibility of dead spots are large due to various hindrances present at the home, due to various appliances that are present, right? So in order to bypass those dead spots, Z-Wave protocol utilize a message which is called healing in order to bypass those dead spots. So the correct option for this is Z-Wave protocol. So Z-Wave protocol basically uses healing message to bypass radio dead spots. Now question number 5. Which of the following nodes send false routing messages in the network? Options are bad nodes, bad failed nodes, all of the above. Okay. So in order to answer this question, we should know that what exactly is bad node, what is badly failed nodes, and what is failed nodes. Okay, so first I'll start with failed nodes basically. So correct option for this is failed nodes, but badly failed node, but I'll explain that what exactly is failed node, badly failed node, and bad nodes. So in case of your failed node, the particular nodes which is present in the network is not going to perform its operation. It can be due to power failure or due to some environmental condition. However, in case of badly failed node, what happened is the particular node is not going to is not going to perform any operation, but at the same time they are also sending the false routing messages. Okay, so the correct option for this is badly failed nodes. Now next question is, which of the following layers provide multiplexing capability in Bluetooth technology? Options are L2 cap, RF COM, SDP, baseband. So correct option for this question is your L2 cap. So I'll discuss all those layers. So basically this is the protocol stack of your Bluetooth technology. So first layer in your Bluetooth technology is baseband, which is corresponding to your physical layer only. So physical radio layer and baseband layer are the two layers which correspond to your physical layer only. Then after that there is L2 cap. Okay, so L2 cap is responsible for your multiplexing. Then these are the other protocols which are used, for example your RF COM, telephony, SDP, all those things are also used in order to provide various services. And then it's the application layer. Now first one is your baseband layer. So baseband layer is a physical layer of your Bluetooth. It manages physical channels and links. The other services which are provided by your baseband layer are your error correction, data whitening, hop selection, Bluetooth security. All these things are provided by your baseband layer only. It also manages asynchronous and synchronous links. It handles packets, paging, and inquiry. So basically baseband layer is responsible for providing error correction, data whitening, hop selection, Bluetooth security, handle packets, paging, and inquiry. Next is your L2 cap. So L2 cap stands for Logical Link Control and Adaptation Protocol. It is layered over baseband protocol and that resides over your physical layer, that is your baseband, and resides in a data link layer. It used to multiplex multiple logical connection between two devices and provide connection oriented as well as connectionless services to the upper layer. It provides the capability of multiplexing, segmentation and reassembly operation, and group abstraction. Third is your RF COM, which stands for radio frequency communication. It is capable it is cable replacement protocol used for generating a virtual serial data stream. RF COM provides binary data transport which emulates EIA 232 control signal over Bluetooth baseband layer. It also provides simple reliable data streams to the user, which is similar to your TCP, and supports up to 60 simultaneous connection between two Bluetooth devices. Next is your SDP, which is your service discovery protocol. It enables application to discover available services and their features. It addresses the unique characteristics of Bluetooth environments such as dynamic change in the quality of service in RF proximity of the devices in motion. It can function over reliable packet transfer protocol and uses request and response messages. Yeah. Basically, what we were discussing is about your Bluetooth technology and the layers. Now the question was that which of the following layer provide multiplexing capability in Bluetooth technology? So options were L2 cap, RF-COM, STP and baseband. So we have studied that L2 cap is responsible for providing multiplexing capability. Next question is, which of the following component can be considered as optional for sensor node? Options are sensing unit, transceiver, location finding unit and none of the above. So first of all we will discuss that what are the different components of your sensor node, and then we will discuss that which of the following is optional. So these are the various components of your sensor node. So first unit or first component is your power unit, which will provide power to your sensor node. Second is your storage unit, as sometimes we need to store the data in your sensor node, so storage unit is necessary. Third one is your processor unit. So in order to provide processing capability to your sensor, processing unit is also necessary. Fourth one is ADC, that is your analog to digital converter, as whenever the sensor sends the data, it needs to convert it to the digital signal before transmitting. So this ADC is also a necessary component. Next one is your sensing unit. So in order to sense the environment, sensing unit is necessary. Then transceiver. So in order to transmit the data or receive the data, transceiver unit is also necessary. Then next one is your location finding unit. So in order to find the location that where your sensor is deployed, we need location finding unit, but this service is not always necessary or required. So the optional component in sensor node is your location finding unit. Next question is, which of the following provide energy to peer-to-peer tags? Options are reader, second option is own power source, third option is both A and B, and fourth option is doesn't require energy. So before answering this question, there are two types of tags in your NFC technology. First one is your active tag and second one is your passive tag. So basically your peer-to-peer tags are active tags only. So okay. So in case of your active tag, they have their own power source. Okay. However, in case of your passive tags, the power is taken by the tags from the reader. Okay. So the correct option for this question is your own power source. So basically these peer-to-peer tags have their own power source. Next question is, which of the following scheme re-establish the connectivity between dumb nodes with others? Options are CORD, CORAD, both A and B, none of the above. So basically in your wireless sensor network there are various dumb nodes present. Dumb nodes means these nodes can sense the data, however they cannot transmit the sense data due to some conditions. Okay, so in order to improve the throughput or in order to improve the performance of your network, it is required that these dumb nodes should be connected to your network and they should be able to exchange the messages. Okay, so there is a need of re-establishment of connectivity between your dumb nodes and your other nodes. So the methods which are used or the schemes which are used in order to re-establish the connectivity between your dumb nodes with your other nodes are your CORD and CORAD. Both these schemes are used in order to establish the connectivity. So these are the links where you can read about these two techniques, whereas other techniques which are used are CORD, WAC, LEC, RAD. Now next question is which layer of Bluetooth handle paging? Options are L2CAP, RFCOM, STP, baseband. This thing we have discussed few minutes back only. So the correct option for this is paging. Baseband. This baseband is responsible for providing paging, inquiry, for data whitening, for providing security. Although these functionalities are provided by your baseband layer of Bluetooth. Now paging, what does this paging mean? So this is the process of forming connection between two Bluetooth devices. Now these are the features of your baseband layer. So it is the physical layer of Bluetooth. It manages physical channels and links. And the other services which are provided by baseband layer are error correction, data whitening, hop selection, Bluetooth security. It manages asynchronous and synchronous links. It handles packets, paging and inquiry. So correct option is baseband. Next question is, in journal, is it advisable to increase the duty cycle of a node in case of rare events for social sensing? Options are yes, no, not applicable. So if we are going to increase the duty cycle, it means that we are keeping your sensor nodes awake for long time, right? So in case of rare events, if we are going to do so, then we are just wasting the power or energy of your sensor devices. Their lifetime will become short. As the event is rare, it will take after long time and your sensor is going to be used for a long time without any function. So it is not advisable to increase the duty cycle of a node in case of rare events. So correct option for this is no. Next question is ZigBee Pro compatible with ZigBee RF4CE? Options are yes, no, not applicable. Basically these ZigBee Pro, ZigBee RF4CE and ZigBee IP are incompatible with each other. So the correct option for this question is no, because all these protocols, that is ZigBee Pro, ZigBee RF4CE, ZigBee IP are incompatible. Next question is, which of the following is true? Options are scatternet is a subset of piconet, piconet is a subset of scatternet, a device can be mastered in more than one piconet, a piconet can have maximum of 10 scaternets. So the correct option for this is B, as your piconet is a subset of scatternet. So scatternet is a superset of your piconets, where various piconets which are adjacent to each other are combined or are grouped into one scatter-net. And since it is written that a device can be mastered in more than one piconet, so this statement is not true. A device cannot be mastered in more than one piconet, but it can act as slaves in different piconets. And a piconet can have maximum of 10 scatter-net. This statement is incorrect, because piconet is a part of scatter-net. Scatter-net is not a part of piconet. So this is showing, this figure is showing that what exactly is piconet, what is scatter-net. So basically, whenever devices interact with each other, they form a network which is called your piconet, and scatter-net is the superset of different piconets which are adjacent to each other. So this is the correct option. B is the correct option. Next question is, which of the following suffers in case of total cooperation in wireless ad hoc and sensor networks? Options are network delay, network throughput, nodes lifetime, all of the above. Correct option for this is nodes lifetime. So basically there are two techniques used in your wireless ad hoc networks. First one is your total cooperation, and second is total non-cooperation. So if there is total cooperation between all the devices which are present in the network, then the intermediate nodes between the two sensor nodes will send the data whatever they receive. Okay, they are going to exchange the data. So in that case, if every time they are going to exchange the data, their power is utilized, right? And if their power is utilized, their lifetime will become short. And however, if there is no cooperation, it means the intermediate nodes or the relay nodes are not going to send the data or exchange the data. So in that case, their energy is not used, so their lifetime will remain fine. But since the network, since in that particular network the messages are not exchanged, due to which the throughput of the network gets suffered, right? So in case of total cooperation, the lifetime of the nodes will get suffer, and in case of total non-cooperation, the throughput of the network will get suffer. So this is what I have discussed, that in case of total cooperation in wireless ad hoc networks and sensor networks, all the requests are accepted. This exhausts the limited energy of the nodes. However, in case of your non-cooperation in wireless ad hoc and sensor network, all requests are not accepted. This slows down the network throughput. Now, next question is, does ISA 100.11a support tunneling mode? So correct option for this question is yes. So basically this ISA 100.11a application, there is application layer which is tunneled application. Okay, so this for tunneling mode. Next question is, which of the following handle packet paging and inquiry in Bluetooth? Options are L2 cap, baseband, RFCOM, physical radio. So correct option for this is baseband. So we have discussed this thing already, that baseband layer is responsible for packetizing, paging and inquiry in Bluetooth. Next question is, which of the following incorporate channel hopping after every packet transmission? Options are ZigBee, wireless HART, 6 low band, none of the above. So this channel hopping thing we have discussed in first question of this session, that in case of your wireless HART, channel hopping is used in order to provide security. So the correct option for this is wireless HART. And the main major difference between your wireless HART and ZigBee is the incorporation of channel hopping after every packet transmission. So basically in case of ZigBee there is no such kind of hopping, whereas in case of your HART there is channel hopping. Now next question, that is question number 18th, is in X protocol a central network controller device sets up a network with one network ID and multiple node IDs for the devices in it. The nodes with different network IDs cannot communicate with each other. What is X? Options are Z-Wave, ZigBee, Bluetooth, ISA 100.11a. The correct option for this question is Z-Wave. So in case of Z-Wave there is one controller which is going to control all the devices which are present in the network, and there is one network ID which is provided to the entire network, and there are multiple nodes IDs which are provided to the devices which wants to communicate with each other, and the length of the network ID is 4 byte, whereas the length of the this node ID is 1 byte only, and this is these things are used in Z-Wave. So Z-Wave for home automation, Z-Wave is used, and in Z-Wave this one network controller is used, and a network ID is provided, and multiple node IDs are also provided. Next question is, in context of sensor web, sensor ML stand for sensor modeling language, sensor machine language, sensor markup language, none of the above. The correct option for this question is sensor modeling language. Next question is, which of the following protocol is best suited to provide interference-free communication while minimizing latency and ensuring quality of service? Options are wireless HART, ISA 100.11a, both wireless HART and ISA 100.11a, none of these. So the correct option for this question is ISA 100.11a. So basically both these wireless HART and ISA 100.11a have the mechanism to tackle channel interference. However, in case of your ISA 100.11a, it provides ports for legacy technology integration as well as minimizes latency and ensure quality of service. These features are not explicitly present in your wireless HART. So the correct option for this question is ISA 100.11a. Next question is, which of the following solution approach is used to overcome the limitation of ineffective wake-up and sensing under rare event monitoring scenario in social sensing? Options are duty cycle management, sleep cycle management, packet transmission management, both duty cycle and sleep cycle management. The correct option for this is duty cycle management. So duty cycle management is responsible for responsible for the backup of these devices. So in that case duty cycle management is used. Next question is, which of the following technique Bluetooth master uses to avoid collision during transmission in Piconet? Options are frequency division multiplexing, frequency hopping spread spectrum, time division multiplexing, and next one is your direct sequence spread spectra. So correct option for this question is time division multiplexing. In case of your Piconet in Bluetooth technology, time division multiplexing is used in order to avoid the collision between different users who wants to send the data. So in Piconet, Bluetooth master is responsible for the transmission control by dividing the network into series of times slot amongst the network members, and these network members are going to use those time slots in order to send the data, and the length of each time slots in case of your Bluetooth is 10 millisecond. Next question is, which of the following limitation is faced by total cooperation in wireless ad hoc networks? Options are decreasing network throughput, second option is decreasing energy, third is both A and B, fourth is no limitation exists. So in case of your wireless sensor network, if there is total cooperation between different devices which are present in the network, then every time whenever there is some exchange of messages, the energy of intermediate nodes or the relay nodes is used. So basically this is going to decrease the energy of these nodes. So correct option for this question is B, that is decreasing energy. Next question is, which of the following can function over a reliable packet transfer protocol? Options are L2CAP, Service Discovery Protocol, RFCOM, Physical Radio. So Service Discovery Protocol in Bluetooth can function over reliable packet transfer protocol. So correct option for this question is B. Next question is, in which of the following mode NFC device can act as both reader as well as tags? Options are reader writer, P2P, emulation. NFC devices can't act as both readers as well as writers. The correct option for this question is P2P. So basically in case of your NFC devices, peer-to-peer mode is there, in which both the devices can exchange the messages. So in case of your peer-to-peer, both the devices can act as readers as well as tags. Next question is, in wireless sensor networks, information theoretic self-management controls the transmission rate of node by adjusting nodes duty cycle, lifetime, sleep time. Can't control the transmission rate. Correct option for this question is sleep time. Next question is, which of the following layer of ISA 100.11 is port mesh routing? Options are network layer, data link layer, transport layer and MAC layer. So mesh routing is handled by your data link layer of ISA 100.11a. So correct option for this question is B. Next question is, which of the following is used to avoid interference prone channel in HART? Options are channel blacklisting, channel switching, channel hopping, super frame. So by doing channel switching every time, that you are going to avoid interference prone channels. So correct option for this is channel switching. Next question is, when the device are not in range, messages are routed through different nodes to bypass obstruction created by household appliances or layouts. Which of the following exhibits such characteristics of avoiding radio dead spots? Options are Bluetooth, 6-low-band, Z-Wave, Zigbee. So in case of your home automation, Z-Wave was invented. So in order to avoid those radio dead spots, healing message, the use of healing message is done by Z-Wave. So correct option for this question is Z-Wave. Next question is, which of the following is true in terms of power and range of classes of Bluetooth devices? Options are class 1 power 100 megawatt and range is 100 meter, class 2 power is 2.5 megawatt and range is 100 meter, class 1 power is 2.5 megawatt, range 100 meter, class 2 power is 100 megawatt and range is 100 meter. So correct option for this question is A, that is for class 1 the power should be 100 megawatt and range should be 100 meter. So these were the questions of your week 3.